Hello guys, this is Aranima Mukherjee and I'm currently pursuing BTech first year from Institute of Engineering and Management Salt Lake. My branch is EC and currently for the first year first sem we were asked to do a physics project on underground cable fault detector. And although we are not yet ready with the working model, but somewhere or the other we have got a huge overview about this topic and how it works, the components we have been using to build this project. And I think this would help you guys to learn a little more about this topic somewhere or the other, which would be helpful for the first year students. So, firstly, as I introduce this project, I would like to say even the last cables of the decade were meant to put the overhead and is currently put to the other underground cable that is superior to the previous method. Because the underground cable are not affected by adverse weather conditions such as storms, snow, heavy rain, as well as pollution. But when any fault occurs, it is very difficult to locate the exact position of that fault due to the position of the cable. When it is easy to detect and correct the faults is overhead line by mere observations, it is not possible to do so in any underground cable. As they are not buried deep in the soil, it is not easy to detect the abnormalities in them. Even when a fault is found to be present, it is very difficult to detect the exact location of the fault. Keeping this in mind, we have planned or we were told to design the underground cable fault detector using an Arduino, which was provided by our college. So basically the types of cable faults that would occur were open circuit fault, short circuit or cross circuit fault, ground or earth faults. Now what is open circuit fault? Open circuit fault is a kind of fault that occurs as a result of the conductor breaking or the conductor being pulled out of its joints. In case of short circuit or cross fault, this kind of fault occurs when the insulation between two cables or between two multi-core cable gets damaged. Ground or earth faults, this kind of fault occurs when the insulation of the cable is damaged. The current will flow through the fault cable starts flowing from core of the cable to earth or the sheet of the cable. Fault location methods. Basically, when we were having an overview about this project, there were a few types of fault location methods that we came to know, and they basically were online methods and offline method. And under offline method there were a few subparts like the tracer method, the sheet coil method, the terminal method. For online method, to determine the fault points, this method utilizes and processes the sampled voltages and current. Online method for underground cable is less than overhead lies. Offline method. This method uses special instrument to test out service of cable in the field. The offline method are as follows: the tracer methods, the sheet coil methods, and the terminal methods. Apart from this, the hardware used for this were Arduino microcontroller. I would display the Arduino code here, right here. This Arduino code, we like we like worked a lot to get this proper code for the proper working of the thing. And power supply, obviously we have power supply, analog to digital converter, LCD, liquid crystal display, and a lot more things actually. We needed a 10k resistor, 100R resistor, then we needed relays, LCD lights, and transistors. Yeah, that's basically most of it. And the working process now. Working of this project is divided into four parts: DC power supply part, cable part, controlling part, and display part. DC power supply part consists supply of 230 volt AC. Then it is stepped down using transformer. Bridge rectifier converts AC signal to DC, and voltage regulator is used to produce constant DC voltage. The set of resistors denote the cable part along with switches. The set of resistors and switches are used as fault creators to indicate the fault at each location. This shows by the current sensing part of the cable. The change in current is sensed by this part by sensing the voltage drop. Controlling part uses the analog to digital converter to input current sensing signal from the current generating circuit to the voltage drop into digital signal and supply the microcontroller. The microcontroller makes necessary calculations regarding the distance of the fault. The driver is ran by the microcontroller and controls the switching of the relays for proper connection of the display of the cable at each phase. Display part consists of the LCD display interface to the microcontroller, and it shows the status of the cable of each phase and the fault distance of the cable and the particular phase. In case of any fault, and GSM used to send a message to the base station, buzzer is used to alert the field. So basically, as soon as the fault is detected at a particular position, the LED light, it blinks and a signal is sent, and then the distance between the fault is calculated and displayed in the display box that we put. Now the advantages that have been seen through this project provides precise accuracy determining the location of the fault, consumes low power, and compact size, obviously easy to handle. The machines that we use nowadays are large. It's like comparatively it is larger than the thing we have designed or we will be designing soon under process. So basically it's like a lot compact and a lot smaller in size than the big machines that are used for the detection of the cable fault. And the limitations that we have to keep in mind while developing this are the Arduino and other components require 5 volt DC supply. Relay requires 12 volt DC. Sometimes network problems for rural areas may happen, and angular value required time to reach, so more delay occur. So basically this is more or less about the thing we have learned through this process of learning about this project. And here is the circuit diagram right here. Here's a circuit diagram. This is the circuit diagram or the diagram we are keeping in mind while designing the thing. And I have already given the Arduino code before, and it will be also given in the description. And I hope this video was helpful for you guys, and I hope somewhere or the other this will help you guys gather a little more knowledge about this topic. And that's all for today. Thank you so much for joining me, and all the best. Have a great life. Bye bye.